Okay, this is a brief presentation on compound symmetry and sphericity. First, we need to understand and consider what is covariance. A lot of students are thrown off by the term covariance. Lots of syllables, covariance, well, not that many. But really, it's nothing fancy. It's very much related to correlation, such that correlation is the standardized version of covariance. So if you take the covariance of two variables, let's say x and y, and divide it by the standard deviation of each, you get the correlation. So correlations are just standardized covariances bounded by -1 to 1 versus covariances, they're not bounded because they're not standardized. So always think of correlation as a standardized version of covariance, and covariance is the unstandardized version of correlation. So it's like the raw cousin of correlation. That's covariance. So now let's discuss compound symmetry with an example, and I just made this up. Okay, so you have Jane, who participates in a research study where she's asked to take 3 different tests across time. For the assumption of compound symmetry to be met, the covariances of each pair of variables must be equivalent. So I drew a figure below and have test 1, test 2, and test 3. And so the covariances, or the unstandardized correlations between each test, must be equal. Plus, the B's, or the variances, also must be equivalent to satisfy our assumption of homogeneity of variances. Then we go down. We see that this is kind of overkill because it's a very difficult assumption to meet. So to have the HOV met, plus that the differences between, or the covariances between the A1 sub A2, A sub 3 are all equivalent. The covariances of the unstandardized correlations are equivalent. So we have the assumption of sphericity as a replacement, which is much less restrictive and requires only that that B sub 1 minus B sub 2, or the difference between the variances between test 1 and test 2, and the differences between B2 and B3, and the differences between B sub 1 and B sub 3 are all equivalent. So this is a relaxed assumption. So this is saying, sphericity says, okay, you have to meet HOV like always, right here. And now you have to meet that the differences between the variances between tests are statistically equivalent and equal, versus the covariances in the assumption of compound symmetry, which is a much more stringent condition. Then it's important to note one more thing, is that the assumptions of compound symmetry and sphericity only come into play when there are 3 or more conditions. Because what happens when you have 2 tests, like in this example? So you have test 1 and test 2 only. In that sense, you only have 1 difference, or 1 covariance here. That's all you have. You only have A sub 1. So saying that A sub 1, oh, zoomed out. A sub 2, let me get that taken care of. Zoom out. Okay, A sub 1 and A sub 2 is a null concept because you only have A1, or only have the difference between B sub 1 and B sub 2. So of course they're equal to themselves. This has been a brief presentation on compound symmetry and sphericity. Good luck in your homework.